Assalamu alaikum wa rahmatullahi wa barakatuh. So in this video I will show you how to implement a doubly linked list. So what is the difference between a linked list and a doubly linked list? In a linked list we have just a pointer with the name head which point to the first node, and a node in the linked list has two attributes, the data and a pointer to the next node. This node will point to another node, which point to another node, and the last node in the linked list has a null pointer in the next. Now, in a doubly linked list, the node contains two attributes, the previous and the next, and we have the data here. So each node will point to its next node, and it will point also to its previous node, and the same thing, this node will point to this next, and the previous here will point to the next. So the first node will contain a previous equal to null, and the last node will contain a next which equal to null, and we have two pointers ahead which point to the first node, and a tail which point to the last node. So the first step is to create the class node which contain the data, the previous and the next, and then we will implement our doubly linked list. So we go to Visual Code. The first thing is to create the dnode class. Dnode means doubly node.java. So we have class dnode. As we said, we have the data, int data, and two pointers. The first pointer point to dnode previous, and dnode next. The constructor public dnode will contain, so when we create a new node we have to give the value of the data. So we will give an x as parameter, an integer x, and data will be equal to x, and the previous equal to null, and the next is equal to null. And that's it for the class dnode. As I said, we will create now the doubly linked list class. So we will create a new file, double linked list .java. So a double linked list contains two attributes, or two pointers. The first pointer of type dnode, we have the head of the list, and we have also a dnode for the tail of the list, which is the last element. So when we create a doubly linked list, we will create an empty doubly linked list. So the constructor public doubly linked list, we don't give any parameter in the constructor, just we will create an empty linked list. What does it mean, an empty doubly linked list? That means that the head will be equal to null, and the tail will be equal also to null. Okay, now we move for the method empty. How do we know if our lists or our doubly linked list is empty or not? Just we will implement the empty method which return a boolean empty or is empty. Check. So return head equal to null, or return tail equal to null. We don't have to check both, because if the head will be equal to null, automatically the tail will be equal to null. Adding a value in the front. So we will add a value x in the front of the list. We have two scenarios. The first scenario is when the list is empty. So we have a head equal to null and the tail equal to null. In that case, we will create our node. We will put x in the data, and this node will have in this node we will have a previous equal to null and the next equal to null. And for linking with the list, just we will make the head pointing to this node, let's say the node P, and the tail also will link to this node. This is the first scenario. The second scenario, if we have already some elements in the list, so the list is not empty. In that case, the tail will not change. So when we create a new node, we will put x in the data of this new node. We will change the next of this node, let's say the node P. The next of P will be equal to the head. So the next will be equal to the head. P dot next will be equal to the head. And also the head dot previous will link to the new node. Okay, here we get the head dot previous will be equal to the head to P. P dot previous will remain null, and the final step is to update the head. The head will be the new element. So the last step, head will be equal to the P, and that's it. So this is the two scenarios, and now we move to the implementation. So we have void AddFront int x. In both scenarios, we will create a new node. So d node P will be equal to new node, d node, with the value x. And then, if the list is empty, P dot next and P dot previous will remain null. Just we will make just the head will point. We will point to the new node, and the tail also will point to this new node. So head will be equal to P, and tail will be equal to P. Else, now we already create the node. We have the previous equal to null, the previous will remain null also, but now the p.next will point to the head, and then head.previous will point to the new node p, and finally the head will be the new node p, and that's it. Adding an element at the end have two scenarios also. The first scenario where the list is already empty and we have the head which is equal to null and the tail equal to null also. So in that case just we can call AddFront without re-implementing anything. The second case where the lists contain already some elements. So let's take the case where we have the head and the tail pointing to an element. Okay, so to add at the end, just we will update the tail in that case, and just we will create a new node. We will put x in the data. This new node will have next equal to null already. So the first step is to link the previous of this node p with the tail. So p dot previous will be equal to tail, and the second step, the tail dot next will be pointing to the new element, to p, and finally just we update the tail to be the new element. So tail will be equal to p. We move for the implementation. Void AddEnd int x. So the first thing is to check before creating. If the list is empty, then just we call AddFront with the value x. Else, the first thing is to create a new node, p equal to new node dnode with the value x. This new node will have a previous equal to null and the next equal to null. So we update the previous. P dot previous will be equal to the tail, and tail dot next will be equal to the new node, and the last thing is to update the tail. Tail will be equal to p, the new node, and that's it. Adding after a value, adding x after a value existing in the list has two scenarios. The first scenario, if the list is empty, in that case we will perform no add. Why? Because the value doesn't exist. Okay. The second scenario, if not empty, let's say that we have this list. We have the head pointing to a node, that's point to another node, pointing to another node, and this is the last, and this is the tail, and this is the head. So the val is the first or the second element. Let's say the first. So what we will do, let's say I will complete this. Simply we will create a new node, P. We will put X in that node, and we will create another pointer that will look for the value of val. So we will create a pointer, let's say n, and we'll check if this node contains the val. Okay, if it is it's not containing the val, it will move to the next node, and so on. So now we have a pointer n for the node containing the value that we are looking for. And just what we will do, the first thing is to make the next of P equal to n.next, and the previous of P is equal to n, and then n.next will be equal to P, and P.next.previous will be equal to P. There are many ways to make the linking, okay, and this is one way that we can use it. So the first thing is P.next will be equal to n.next, P.previous. We will begin by next and previous of this the new node. P.previous will be equal to n. Now we have to make this link for this one. So we will have this one is n.next.previous. Okay, so n.next.previous will be equal to P, and for this link n.next will be equal to also P. So there are 4 steps. Okay, this is for the case where the value is the first or the second, and as you see here, the value is not the last element. So if the value is the last element, we will have a small problem. We don't have the next previous. There is no next after this node. So we have to check before making this line. Or if the tail dot data equal to val, in that case just we will call AddEnd x, and this is the simplest way. Okay, if the val doesn't exist in the list, means that the n which is looking for the val, if n reach the last element and the last element doesn't contain the value of val, we will not perform an adding, and the list remain without adding the value x. Now we move for the implementation, and we will try to make every step one by one. We will begin by checking if the list is empty or not. So void AddAfterVal int val and int x. So we will add x after the value val if not empty. Is empty. So if the list is not empty, we will perform the adding. Now we will check, just a fast check, if tail. Now we are sure that the list is not empty, so we have a tail and we have a head. If tail.data is equal to x, just we will call AddEnd x. Else, here we will create a new node. But before creating the new node, we have to check if the value exists in the list or not. So the first thing is to create a pointer, a dnode n. This dnode will begin by the head. And what we will do, while n dot next is different from null, we have to check also n dot data is different from x, from the value that we are looking for, and n dot next is different from null. What does it mean, this condition? So while we didn't find the value that we are looking for, and while we didn't reach the last element in the list, so n we will be equal to what? To n dot next. So if we reach the last element, means that we didn't find the element. So if n dot next is equal to null, that means that what? That means that we didn't find the value. So if n dot next is different from null, in that case, so we are not in the last element. We are. If we are not in the last element, means that we have found the element. If it reached the last element, means that we didn't find the value, because if the value was in the tail, we will not access the else. Okay, so in that case we will create a new dnode p with the value x, and then we will start linking this new node p dot next will be equal to n dot next, and p dot previous will be equal to n dot next dot previous will be equal to the new node p, and finally n dot next will be equal to the new node p, and that's it. RemoveFront requires a non-empty list, and there are two scenarios. The first scenario, the list contains one element. In that case, we will have the head is equal to the tail. In that case, just we make the head and the tail equal to null. The second scenario is when we have many items and so on. This is the head. So just to remove the front, we move the head forward to the next element and we make the previous of the new head equal to null, and that's it. Now we move for the implementation. Void remove front. So if not is empty, the first scenario, if head is equal to tail, in that case just we put head to null and the tail will be equal to null. Else there are many items or many elements in the linked list. In that case just the head will be equal to the head dot next, and the head dot previous will be equal to null, and that's it. Removing the end also requires a non-empty list, and if there is only one element, so the head will be equal to the tail will be equal to null. Otherwise, if you have many elements, in that case that will take the case. So we have many nodes and you have the last node who's pointing to, and so on, and we have this tail. So we move the tail backward and we put the new last element, the next of the new last element, to null, and that's it. We move for the implementation. So we have void remove and we check the list. If not is empty, then if there are one element, if head equal to tail, then head will be equal to tail will be equal to null. Else the first thing is to move forward the tail. Tail will be equal to tail dot previous, and tail dot next will be equal to null, and that's it. Removing a value from a doubly linked list. So of course in this method, if the list is empty or the list doesn't contain the value that we are looking for, we will not perform the remove. So if the value exists, there are three scenarios. The value may be in the front, maybe the value in the tail, and maybe the value is inside the list. In case where the value is in the head, we just call RemoveFront. In case where the value is in the tail, we call RemoveEnd. The other case, we will suppose that we will remove this item or this element. Suppose that we find the element val in the element p. So what we have to do is to link the next of the previous p with next of p. So p dot previous dot next will be equal to p dot next, and we link the previous of next of p with the previous of p. So p dot next dot previous is equal to p dot previous, and that's it. We move to the implementation. Void remove a value int val. So we have to check if the list is not empty. If not is empty, and we will create a pointer p that we will that begin from the head to the tail, and we will look for the value val inside this list. So dnode p will be equal to head, and while p dot data is different from the value that we are looking for, and p dot next is different from null. There are more items null, and p will be equal to p dot next. So after this loop while, maybe we find the value, maybe we did not find the value. So if p dot data is equal to the value, means that we find the value, so we will perform the delete. Else we will not perform, we will perform nothing. Okay, so if the data is equal to val, so maybe the element is the first element. In that case, we have to check if p dot previous is equal to null, means that the element containing the value is the first element. So we just call RemoveFront. Else, if p dot next is equal to null, means that the element is the last, so we call RemoveEnd. Else, we perform the linking. So as we said, p dot previous dot next will be equal to p dot next, and p dot next dot previous will be equal to p dot previous, and that's it. To print the list from the head to tail, or the reverse from the tail to head, we will create a pointer p that begin from the first element, and to print just p will print the data, then go to the next, then go to the next, till reaching the next equal to null. For print reverse, we will make the pointer p that begin from the tail, and each time it go to the previous until it reach the first element in the list. So we move to implementation. Void print. The first thing is to check if the list is not empty, and then we create a pointer p that begin from the head, and while p is different from null, we will print p dot data, and we add a little space between each printing, and we will perform system.out.print, and then p will be equal to p dot next. To print reverse, I will make a copy and paste for the print method. Print reverse. Also, we have to check if the list is not empty, and the pointer will begin from the tail, not the head. And while p is different from null, we will print the data and p go to the previous. And that's it. We move now for the testing part. To test, you have to create a new file, tests.java. In this class test, we will add a main method, and now we will create a doubly linked list. So double linked list dl will be equal to new double linked list. We can add dl dot add in front. I will add 10, add in front 20, dl dot add end 30, dl dot add after a value after 20, the value 25, and print no, I will not print. I will call dl.print. It will print all the list. If we test, we get 20, 25. 20 is the front because it was inserted in the front after 10, so 20, then 25 is after 20, then 10 and 30. We can delete dl.remove RemoveEnd, and we should get the list 20, 25, 10, 30, and 20, 25, 10. We can make a sysout here to return to a new line. And that's it. Hope that this video was benefit to you, and see you in other videos. Thank you.